Okay, hello class F. This lesson today is on experiments with data. It's a little bit more of a calculator heavy lesson, so I'm making sure that I'm the one giving you the lesson and I'm not using one I found online. So at this time, please get your calculator out and just put it off to the side for a moment. Okay, so I'm going to start with the lesson. And you should have your guided notes out in front of you next or with a pencil so that you can be filling in your lesson as we're going through the slides. So today we're going to talk about different kinds of experiments with data. So before we get into this, let's quickly review what a scatter plot is. A scatter plot is a graph that relates data from two different variables. And this is something that we looked into more in depth last year. But for example, we could take everybody's height in this classroom, and then we could take everybody's shoe size in this classroom, and we could plot this different information on a graph. And the graph that would make with all the different people's plots and points for their height and shoe size would make a scatter plot. Now, we could then look at that scatter plot and decide, is there a correlation? Does someone's height relate or correlate to their shoe size? So a correlation is that relationship, if there is one, or if any, between the two variables. So if the two variables do have a correlation, it can be described as positive or negative. So positive is when our graph, let's say we have a scatter plot with a whole bunch of dots and different points of data. If the data in general is going up from left to right, then that would represent a positive correlation. So naturally, in the other direction, let's say we collected a whole lot of data and plotted it, but we noticed in general the data was going down from left to right. That would be an example of a negative correlation. Finally, if we took a whole bunch of data and we saw that there really wasn't any special pattern to where the points fell, we would say there is no correlation. A height versus shoe size would have a positive correlation if we were to actually do this experiment. Usually, the taller you are, the larger shoe size you'll need, generally. So that's probably a positive. So what I've actually drawn on my two examples up here is a line of best fit. So we often use a line of best fit to help us make predictions about where the data might continue to fall, and also to give us an idea of that positive or negative correlation depending on if that line would be increasing or decreasing. So the best fit line or line of best fit, as you'll often hear it referred to, is a line through a scatter plot that best represents the trend. So it's really an estimate of the data. It really will take a whole bunch of your data and, in a sense, average it out and find that middle happy place where we could say, okay, on average, the data is falling along the line. So if we were in class together, I would have everybody line up, or I'd have 3 people start out and hold hands. We did this with a hand squeeze, but instead we would do the wave and pass the wave down and calculate how much time it would take for 3 people to pass on the wave. Then we'd add 2 more, time them, add 2 more, and so on. So let's pretend that we did this exercise as a class and this is the data we found. Our time here is in seconds. So I'm going to give you a moment to copy this data onto your guided notes. So what we're going to do is we're going to take this data and we're going to actually find a line of best fit for the data. So to find a line of best fit for our data, we're going to always start by making a graph of the data. Once we have all of the data plotted on our graph, we're then going to draw a line of best fit. we'll pick 2 points in the data that would best represent a line that would go through and kind of average out our data. If we have those 2 points on that best fit line, well, with all the equation work we've done, we could then write an equation for that line using the 2 points. So find the slope between them, use one of the points to fill into point slope form, and then maybe transform it to slope intercept. So we'd write an equation of the best fit line using the 2 points we choose. So we're going to do this on the next slide. So I'm going to be flipping back and forth to help me fill in my graph, and you should be graphing and plotting the data as well. So here is our graph, and if we look at our table, we have the people in the first column. Remember, your first one's your X, that's our independent variable, and the time depended on how many people were in the row. So our time will be plotted on our Y. So let's make sure we are labeling our axes, time and people. I'm abbreviating. So remember, we always put 0 in the corner. Now, we had people of 3, 5, 7, 9, 11, 13. So I'm going to make sure I have enough. So this would be 3, 5, 7, 9, 11, 13. Okay. And then for the times, we go from 0 to 3 seconds. So I'm going to space these out. And just say this is, let's say 1 second, 2 seconds, 3 seconds. Remember, we're using seconds. Oops, sorry. Okay, so we had 3 people took approximately 0.72 seconds. So I'm going to estimate where it would fall. 5 people took 0.73 seconds. So 5 took 1.3 seconds. So that'd be about right there. 7 people took 1.61, so just above that 1.5 mark. 9 people took 2.05 seconds, so almost exactly 2 seconds. 11 people, 2.25, so about halfway between those. And 13 people took 2.63 seconds. So what we've done is we have plotted all of the data. Now you'll notice that the data is not in a perfectly straight line. Our goal is to now pick 2 points where if we were to connect the 2 points, we'd be able to draw a line of best fit going through the data that really shows a good representation of our trend. We can see it's increasing from left to right, so this is definitely a positive trend. Now, we can't pick any 2 random points. For example, if I were to pick this point and that point and draw my line of best fit through them, then my line would be almost horizontal. And that's really not matching the trend of our data, which goes a little bit more steeply. So this one's actually a little bit of a trickier one, but we want to pick 2 points where if we drew the line through them, they would represent the trend of our data. So where we're getting a little bit hung up here is where we kind of cross over and then continue to go up. It'd be nice to get a line right in the middle of all of that. However, if I were to choose this point and that point, now I'm looking not as steep as the data. So for this example, let's use this point and that point to write our line of best fit. This is where the calculator is really going to become handy today, because the calculator will help us more accurately draw our line of best fit. But we're going to potentially use these 2 points, meaning that we would use 7, 1.61 as an ordered pair and 9, 2.05 as an ordered pair to help us write the equation of the line. We're going to come back to this in a moment. I'm going to walk you through how we'll use the calculator to help us and see if we've actually picked the 2 best points for our line of best fit. Okay, quick little added information here. If you are asked if your data is linear, I just wanted to stress and add this in that doesn't mean is the data in a perfectly straight line. If it says is your data linear, that's really referring to does your data have a linear tendency or trend. So if you can identify that your data has a positive or negative trend, then you are going to say that yes, your data is linear. So for example, here we have linear data. Even though it's not in a perfectly straight line, it is linear. So if we have linear data, that's what allows us to draw a line of best fit through our data. So I just wanted to clarify that. You'll see that on homework, and now you have that in your notes. So let's use our calculator to help us decide if we really did pick the 2 best points. So I'm going to, I want to keep my annotation. So I'm going to back out of the lesson. And let's start following these calculator steps. What we're going to do in our calculator is we're going to take this data from the table and input it into a table in our calculator, and then we're eventually going to have our calculator plot these points, and finally we're going to add a line to estimate the best fit line. So in our calculator, to graph our data, let's go to our home screen and create a new document. So right now, turn your calculators on. And we're going to create a new document. So select new document. And if at any point I get ahead of you, please click pause and catch up, or rewind to listen to my instructions a second time. So as soon as you hit new document, we want to select add list and spreadsheet. So back to the calculator. So I want to scroll down to number 4, add lists and spreadsheet. When I do that, that gives me a spreadsheet where I'll be able to enter my data. Label our columns is the next step. So once you've got this, we need to come up and scroll up to this very top box. And A is going to represent our X column. And if you'll remember in our table, our X column was the number of people. So we're going to write people up here, and it is absolutely fine if you abbreviate this to PPL or maybe just a P. If you'll remember, our Y column is time. So you might just use T or TIME. I'm going to type out people and time. Sometimes you will not be able to write a word in here fully. If your calculator gives you an error message after you try to title your column, that's okay. Just go back and name it something different. For example, if you were trying to name it floor and it says that's an invalid name, then just label it F or FL or something that you can remember what it stands for. All right, once we've got our columns labeled, you need to skip this next row. So this row with the equal sign, you need to skip. Go down to the first row that's numbered below, and now here is where we'll enter the number of people we had in our experiment. So we started with 3. I'm going to type 3, hit enter. The second experiment, we had 5 people. Then 7, 9, 11, 13. And that's to the end of the data we collected. Once you've entered the number of people, let's enter the times it took for each of those. So scroll back up, and for 3 people it was 0.73 seconds. So I'm going to type that in now under the time column. So it's really important that you're making sure that the numbers are all matching up and aligning the way they were in your table of data that you collected. So now I need 1.61. 2.05, 2.25, and 2.63. Take a quick skim to make sure it looks like what you wanted to enter. And if you're feeling comfortable and you're good to go with this, let's go ahead and move on to the next step. So we have now entered all of our data into our list and spreadsheets page. Once you've done that, you can now graph these points. So within this same document, we're going to hit doc, I believe, hold on, insert page. So doc, insert page. To add a page inside of this document, it's very important you don't start a new document. So after you've entered your data, hit doc, insert number 4, page number 2. This time, we need to insert a data and statistics page. So we already did a list and spreadsheet. We now need a data and statistics page. So I've selected that, and what's happened is my points have arbitrarily been scattered about this screen. Now, I have not told the calculator yet which is my x variable and which is my y variable. Remember, in our table, we labeled people and time, so we need to now label our graph. So along the x-axis, the horizontal one, I want you to hover down at the bottom till you see it say click to enter or add a value. So once you're hovering over this box, click on it, and you'll see you get the option to label it people or time. So x-axis was our number of people, so I'm going to click people. I need to do the same thing to the y-axis. So hover over. Once you're hovered over this, click it, and now assign your y-axis to be time. And voila, our points are beautifully graphed on our coordinate grid. Once we've plotted the points, we are now going to really use our calculator to help us figure out which 2 points are the best fit points. Let me just check real quick. Okay, so we now are going to add a line of best fit. So to do this, we're going to use a movable line. It is very important that you understand that this movable line is a tool to help us. It is not the answer to any of your homework problems. It is a tool that will help us pick the best points. Okay, so to get this movable line, we're going to click Menu, Analyze, Add Movable Line. So we've plotted the points. We're going to hit Menu, Analyze, Add Movable Line. This throws a line on our graph. This line, we can Control-click over it to drag it up and down. The other really cool thing about this movable line is we can come, if you hover over the line to the top right, it gives you the option to click and rotate it to adjust the steepness. Or to the bottom part, you can click, if you hover down there, to adjust, I believe Control-click to adjust the steepness there. So remember, our goal is to find a line that will go through 2 points exactly, but that will give us a pretty good average of the general data in our entire graph. So remember, when we talked about this on our own hand-drawn graph, we decided it'd probably be best to use these middle 2 points. So I'm going to adjust my line so that it looks like it is going exactly through those 2 points, right through the middle. And it might take some tweaking of adjusting the top right and top left, moving it up and down. This is where it's fun to play around. You can see that for this, it looks like I've got 3 of my data points below it and 1 of the data points above this line, and 2 of them are on it. While generally we want a good mix of points above and below, I think this would still be an okay best fit line because it's given us a pretty good reflection of the trend of the data. But we can try out some others. Let's say maybe I wanted to try going through this line, or this point, I'm sorry, the 5 people point, and maybe the 9 people point. You can see with this one, when I create this movable line, every single piece of data is below it. Generally, that's not going to be your best fit line. We want to try to have some above, some below. If you tried this last point with maybe that point, That's a little bit closer. So that would be an acceptable best fit line. What you're going to find while we're doing this is I'll often accept several best fit lines that could be correct answers. Let's take a look at, if you'll remember, we said these two up here probably wouldn't be a good best fit line. If I were to get my line going through these, while you can see I have some points below and some points above, it's really not representing the steepness of the trend of our data. So just make sure the best fit line that you decide on really follows the trend of the data. And I think we are going to stick with these 2 points. Once you've decided on the 2 points that would lie on your best fit line, this is when you then pick up your pencil, go to your paper, and find the equation of the line between the points. So I've got some helpful hints on your notes for you to move the cursor to the top where the symbol becomes a rotation symbol to move the line, move the cursor to the center to move the line up and down and parallel. All right. So those are the calculator steps to help you get that movable line. Again, this equation for the movable line that you'll notice adjusts as I move the line, while that equation is mathematically correct, it is not acceptable for you to give me this as your answer. First of all, you know that we need our slopes as fractions. Second of all, you're generally going to be giving me your y-intercepts as fractions as well because your calculator will often have decimal places out too far for you to write on your paper. So you can ignore this equation. It's not useful to us. We're just using the movable line to help us pick the 2 best points that our best fit line should go through. This is going to be definitely more accurate than graphing by hand, which is why we'll be using our calculator this way. Okay. So now that we've decided on our 2 points, we're going to make up our equation using the 2 points that worked for our best fit line. As I said, if you decide on 2 other points that still work, your answer will still be correct as long as your work is fine. So there are often various answers for this type of problem. All right, so let's go ahead and actually calculate the equation of the line we decided on. So we chose the point 7, 1. Let me use a pen. So 7, and the time for that point was 1.61. And we chose the point 9, 2.05. And these should be 2 points on your actual table of data that we had earlier. Okay, so it is now time to calculate the equation of this line. So find your slope and by all means use your calculator for this work. I'm getting mine out as we speak. All right, so for the slope, we're going to subtract the y's. 2.05 minus 1.61 over 9 minus 7. So I'm getting 0.44 over 2. That's a little hard to read. I'll put it down here. 4 over 2. So because of this decimal in the numerator, we need to get rid of it. So we're going to multiply the top and bottom by, we need it to move 2 places, so 100. You'll often get real funky looking slopes in these types of problems. Okay, and finally, let's simplify that to get a slope of 11/50. Okay. Once you've got your slope of 11/50, pick one of the points and your slope and go into point slope form. And we need, before we can graph our line, we need to transform it to slope-intercept form. So I'm going to distribute first. And by all means, well, this will be 77/50ths, but you can use your calculator whenever you need to for distribution. At this point, please use your calculator for this next step. Just add 1.61 to both sides. Make sure you're using negative 77/50ths. And then add, you can type 1.61. And that actually comes out to, convert it to a decimal or a fraction after you do that addition, a positive 7/100ths. So remember, in your calculator, to convert a decimal to a fraction, you'll type menu, number, approximate to fraction. Okay. This is the equation of our best fit line for the 2 points we picked. So the last thing we're going to do to help us check our work is we're going to go back to that document you created. So you could always maybe have saved it, or if you wanted to, you could have added a page for just your calculations in the document. But let's go back to this slide or this page in our calculator that had the data plotted. So remember, this is our movable line. I like to take it and move it out of the way, because ultimately, if we've written our equation correctly, it will fall right where we had it. So we want to move this away and make sure that the line that we're about to plot, that we created, actually falls where we want it to. So we are now going to go, we wrote our equation, we're going to now hit menu, analyze, and this time we're plotting a function. So menu, analyze, plot function. This gives us that space where we can now enter our equation we got. And we got 7/100ths. Don't forget, controlled division gives us that fraction format. And right here in bold is the function that we just plotted. You'll notice this is the one we came up with. If you click on it, you cannot move it. Here's our equation. If it goes through the 2 points you wanted it to go through, then your work is correct. If you plot your function and your line is nowhere to be seen on the screen, then that means you maybe made your y-intercept might be off, or you made a miscalculation. If it's really a crazy diagonal that you weren't expecting, again, you may have made a miscalculation and need to go back and check your work. So that wraps up our lesson. Again, please feel free to rewind, pause, go back to any part of it to help you with the calculator steps. You have the calculator steps typed out on your guided notes as well. So I hope that that made sense. Of course, we will answer questions, and I just want you to do your best on this homework. I will not be grading for accuracy, but I do want to see an effort from you. You'll be needing to use the calculator. You'll be needing to add a movable line to help you decide which data points are best for the data that's given. So again, you'll go back through these slides to follow this process in creating a document. You may want to name your document for tonight's homework as the workbook pages, so that you can save your work. So when we're checking our homework when we get back, you have your calculator work saved. I hope this was helpful. I hope you guys have a wonderful day, and thank you for your time.